Today we're going to start working on reflecting figures in the coordinate plane on the normal graphs that you would see. So to reflect figures in general, you're essentially flipping them over a line. And so to do that in the coordinate plane, you just kind of look at each coordinate of the figure, you count how far it is away from the line, and then you graph it the same distance on the opposite side of the line, okay? And sometimes that's a little easier to do in certain cases than others, okay? And so what we're actually going to do to begin with today is practice finding rules for reflecting things or figures over certain types of lines, okay? And so we will be practicing reflecting, but then you're going to also be practicing finding the rule for that type of reflection, okay? So the first thing that we're going to start practicing is how to find the rule anytime you reflect something over this line right here, okay? So the steps that you want to take is you want to start by graphing this line, okay? And if you kind of remember how to graph it from Math 1, then it'll be easy. But if not, there's some little things you can remember. So to graph a line like this, x equals 0, one thing to remember is anytime it's x equals some number, kind of like that, this type of line will be a vertical line. So that's the first thing you have to remember. And then the other thing, so vertical goes up and down, okay? The other thing you have to remember is it's going to hit, that line is going to hit the x-axis at whatever that number is. So for this one, it's going to hit the x-axis at 0. So if we graphed it, we're going to go to the x-axis to 0, which would be right there, and put a dot, and then it's going to be a vertical line that goes through that. So a vertical line that goes through that would be this line right here. And so if you notice, this is actually the same exact thing as the y-axis. So what we're doing is we are actually learning how to reflect a figure over the y-axis, okay? So one thing that you can always do to help you reflect a figure over any line, really, is you're going to take this point that I'm going to have you actually use. You'll notice I'll have you use it for every single problem that we do with this. You're going to take that point and you're going to flip it over that line, whichever line you're told to reflect it over, and you'll be able to figure out what's called the rule. And so the reason why the rule is so nice to know, or so nice to have, is because the rule is going to tell you in general what happens anytime you take any coordinate and reflect it over it. So once you find the rule, you'll be able to just take that rule, whatever it happens in the rule, because remember the rule tells you what happens to the x and y values. So it tells specifically what happens to the x and y values. So once you have the rule, it's going, all you have to do is apply it to the coordinates that are in your figure. Okay, so that's what we're practicing today, is finding the rule. That way, whenever we start reflecting all kinds of figures, you'll be able to reflect them very easily. Okay, so the first step is you graph the line like what we just did. Then you're actually going to always use this 0.35 to help you get the rule. So if I take that point, I'm going to take it and graph it. So 1, 2, 3, 1, 2, 3, 4, 5. And then I'm going to flip that point over the line. So if I do that, remember to reflect figures or to reflect a coordinate, because it's just a coordinate over that line, I'm going to count how far it is away from the line. So you have to go directly towards that line. So it's 1, 2, 3 units away. So I'm going to go 3 units on the other side of the line. So 1, 2, 3, and that's where it landed. Okay, so to find the rule, all you have to do is find where did it land, and then look at what happened specifically to the x and y values And that's going to tell you what in general happens anytime you reflect any figure over that line. Okay, so where did this land? Well, now it's at negative 3, 5. So I'm going to come down here and I'm going to write down, okay, it originally was at 3, 5, and then it landed at negative 3, 5. And I'm going to look at what happened. All right. Well, originally it was 3, 5, but then what happened to your x and y value? Well, notice the 3, the sign changed, and then the 5, it stayed exactly the way it is. So, to write the rule, you're going to look at what happened to specifically the x and y values. So, the x values, we'll just write it right here, the x value changed sign. So, this sign changed. And then the y value stayed exactly the way it was. So we'll write stayed the same. So how do we write that as a rule? Well, remember, rules start out with just x, y, and then it has a little arrow. And then in the parentheses, you're going to show kind of using an x and a y what happened. Well, to show that the x changed sign, kind of like what was here, you're going to put an x, but then you're going to put a little negative in front of it. Now, that does not necessarily mean that it's just going to become negative, because if it was negative to begin with, what would actually happen is it would become positive. So it would kind of go opposite of what it was. So to show that it became the opposite sign, you put the negative in front, because that's just showing you take that number and multiply by -1, which would change the sign, okay? And then notice the y did not change at all, so if it didn't change at all, you just write a y. And so that is what's called the rule for reflecting anything, any coordinate over that line. Okay, so now if I gave you a figure and I told you to reflect it over the y-axis, all you would have to do is you could kind of remember this rule and memorize, okay, the x's change sign, and you would just go through each one of those coordinates, and you would change the sign of the x value and then keep the y value the same, and there you go. You would have reflected that figure over the y-axis. Okay, so let's do a couple more so you can kind of see different types of lines you could reflect stuff over. So what if this time we had to reflect a figure over y equals 0? Well, just like we did before, we're going to have to graph the line, okay? So if it's y equals a number, the thing you have to remember is these are actually going to be, so when it's y equals a number, these are actually going to be horizontal lines. So I'm going to have to kind of squeeze that in here. So horizontal, it's going to go left and right. Okay, so these are going to be horizontal lines, so it's going to kind of go that way. And then this number tells you where it's supposed to hit the y-axis, because it's y equals that number. So I'm going to go on the y-axis to 0, because it's y equals 0, and I'm going to put a dot. And then remember, if it's y equals a number, it's a horizontal line. So this one is going to look like that. Okay, so they are essentially telling us to reflect this figure over that line. And notice y equals 0 actually happens to be the same thing as the x-axis. It's a little backwards from what we would think, but it actually is the x-axis. All right, so if they tell us to reflect a figure over that, we're going to do the same thing we did kind of a second ago to get the rule. We're going to take that all famous 0.35, and the only reason I have you use that point is because it's kind of easy to see what happened, so you can get the rule from it. But we're going to take that point and we're going to reflect it or flip it over that line, and then we're going to do the same thing we did before. We're going to look at what happened to the x and y values, and then we're going to write it as a rule. So you go over here and you graph the 0.35, 3, 1, 2, 3, 4, 5, and I'm going to flip that point over this line. So when you flip it, it's going to end up on the opposite side of that line. So to flip it, you count directly towards that line, and then you do put it the same distance on the other side. So how far is this away? So 1, 2, 3, 4, 5. It's 5 units away. So I'm going to go 5 on the other side. 1, 2, 3, 4, 5. So it lands right there, okay? So where did it land? Well, let's tell the coordinate of it. So I start at the origin. I have to go right 3 and then down 5. So it lands at 3, -5. So now I'm going to come over here and I'm going to kind of write down what happened. So 3, 5, when I reflected it, landed at 3, -5. Okay, so what happened to the x and y values? So if I look, the x value was 3, and then when it landed, or when I flipped it over the line, it ended up at 3, so nothing changed with the x. So if I go ahead and write the rule, you always started out with x, y arrow. The x did not change, so we just bring the x over, okay? And then what happened to the y value? Well, if I look, the y value was 5, and then it became -5. The sign changed. So to show that the sign changed, you bring the y over, but then you put a little negative in front of it. And that shows you that the sign changed. So if I told you to reflect a figure over this line, you know that you keep the x value the same, and then you just have to change the y value of it, okay, of each of the coordinates, all right? So let's do another one. What if we have to reflect something over the line y equals x? Well, you have to remember how to graph that. And so this one's kind of more typical to what you would graph in Math 1 class. So you need to remember how to graph a line. And so this is actually in what's called slope-intercept form. So it's coming from the y equals mx plus b. So remember the m, the number that's in front of x, is your slope. And then the b, the number that's being added or subtracted to it, is your y-intercept, okay? So if we kind of look at this, it's y equals x. What's the number in front of x? Well, if there's not a number, it's understood to be a 1. And then the number that's being added or subtracted to it, well, there's not one. So that's the same thing as like adding a 0. And so we know the y-intercept is 0. So it's going to cross the y-axis at 0. And then the slope is 1. So that means when I graph it, I have to go up 1, or excuse me, up 1 and then right 1 to graph my line. So you start with the y-intercept. It's going to hit the y-axis at 0. You put a dot, and then you graph the slope. So it goes rise over run. So you go up 1 and right 1 to graph that line. Up 1, right 1. And that, the slope tells you the steepness, so it kind of helps you to know the direction and how steep the line is. Okay, and then to go the other way, you do the opposite. So you go down 1 and left 1. So here's the line. And so once you get the line graphed, you're going to draw your line through it. And if you need to use like a ruler or the edge of a sheet of paper so you can make a nice straight line, that's not a bad idea. Okay, and then to find the rule, to figure out what happens in general when you reflect something over that line, you're going to do that same point. You're going to graph that 0.35, and you're going to flip that point over the line. So I go 3, 5, so 3, 1, 2, 3, 4, 5. And so that's where it originally was. And I'm going to flip it. So this one's a little weird because it's kind of at a diagonal. But if you notice, if you kind of look closely enough, so I'll zoom in just a bit, you'll see that this point is like kind of one diagonal away, because remember you have to go straight towards it. So you're going to go one diagonal on the other side. So that is where it landed. And now all we have to do is tell the coordinate of that point and look at what happened. So it ends up being at 5, 3. So let's see what happened to my x and y values. So it's 3, 5. When I flipped it over that line, landed at 5, 3. What happened to the x and y's? And so this is kind of strange, but if you look, they actually flip-flopped. They switched places. And so that is what happens when you reflect something or a figure, a coordinate, whatever, over that line. Is it's going to take each of the x and y values of that figure, and it's going to flip-flop them. So to show that in a rule, you always start it with x, y arrow. You literally flip-flop the x and y. So the y will come up front, and then the x will go behind. Okay, so if I told you to reflect something over the line y equals x, you take each coordinate in the figure and you just flip-flop the x and y, and that's where it would land if you flip it over that line. So these rules are really nice once you have them. You just need to know how to read them, okay? And that's what we're practicing. All right, let's do one more, and then you'll be able to kind of find rules for reflections fairly easy. All right, so what if they told us to reflect something over the line y equals negative x? Again, this is kind of like in slope-intercept form, so let's figure out what our slope and our y-intercept is. So if it helps you to write that down, you can. And then I'm going to write this equation right underneath it, so it's y equals negative x. And then we have to figure out what these numbers are. So what's the number in front of x? Well, it's technically like a negative 1 in front. And then again, if nothing's being added or subtracted to it, it's like plus 0. Okay, so the y-intercept is 0, so it means it's going to cross the y-axis at 0, so I start there. And then the slope, remember you have to think of the slope as a fraction, so it's like a negative 1 over every number is understood to be over a 1. So to graph this line, I have to go down 1 and right 1. So if it helps you to write that, then write that. So we have to go down 1 and right 1 to graph that line. So let's do it. So we go down 1 and right 1 so that I can graph my line. And notice I just keep following that same pattern, down 1 and right 1. Then to go the other way, you do the opposite. So you go up 1 and left 1. And then once you get your line graphed, you just draw your line through them. And then again, you can use a ruler or the edge of a sheet of paper so you can make a nice line. And then, so if they asked us to reflect something over that line, we're going to use that all famous 0.35 again. So we're going to do like we did before. We're going to graph the 0.35. 3, 1, 2, 3, 4, 5. And then I'm going to count how far that point is away from the line, and then I do the exact same thing on the other side. So this one might be helpful to actually maybe grab like the edge of a sheet of paper or something like that. So I'm just going to use like a sticky note that I have. And the reason why this one's a little harder is because that point is further away from the line. So remember what I talked about before, you want to kind of go straight towards the line. So if you line up like one side of the paper with the line and then the other side with the point, it kind of helps you to focus in on how far it is away. So because it is at a diagonal, again, I'm going to have to count at a diagonal. So I'm going to count how many diagonals it takes to get straight towards that line. So that's 1, and it does help to draw them. 1, 2, 3, 4 diagonals. So I'm going to keep going kind of along that same line, and I'm going to count 4 diagonals on the other side. So 1, 2, 3, 4. There we go. That's where it lands. And then just like I did with all the other ones, I'm going to see what is the coordinate of that point now. So I have to go left 5 and then down 3. So left 5 was a -5 and then down 3 was a -3. So let's look at what happened to my x and y. So 3, 5 became -5, -3. What happened? Well, there was a lot that happened. Kind of if you compare what happened before, do you see how like the x and y's flipped? But then also the signs changed for both of them. So there's a whole lot going on here, all right? So you would say, like if you wrote it out, you would say that the x and y's flip-flopped or switched places. But then also the x and the y both changed signs. So to show that, you put x, y arrow. Go ahead and flip-flop them. So the y and the x are going to flip-flop. But then if you think back, how do I show that the signs changed? You put a little negative in front of them. And that'll just remind you, whatever the x is, I have to change the sign. Whatever the y is, I have to change the sign. And so there you go. That is how you find rules for like reflecting figures over different lines.